Before we go through this next part, I just want to remind you guys that the pi key on your calculator is going to give you the best approximation of the number pi. Okay, so we're always going to wait till our last step to round. So you may recall in like pre-algebra, you just use 3.14 all the time. Okay, well this time we're actually going to use our calculator approximation to get the best possible answer. Okay, so let's look at one example problem here. Okay, this one's actually pretty easy, so we're just going to do one example. Okay, this just says like this pizza making kit. It has 3 circular baking stones with diameters of 24 centimeters, 36 centimeters, and 48 centimeters. So it wants us to find the area of each stone and then round to the nearest tenth. Okay, so this will be a calculator-based problem, but the first thing I'm going to do here is maybe just to draw a pretty simple picture of this. So I'm just going to draw like 3 different sized pizzas, okay, or stones anyways, okay. Obviously these are not to scale, all right, but I'm just going to maybe draw some diameters on these, okay. They're hopefully going to go close to through the center of the circle, okay. So again, diameter here, and diameter here, okay. And they told us that those specific diameters were 24, 36, I suppose I can attach centimeters on there. That'd be a good thing. Okay, and then 48 centimeters. Okay, and they want to know, again, they want to know the area of each one. Sorry, that's 48 centimeters. Erase that here. 48 centimeters. Okay, so in each of these examples, we're just using our formula for the area of a circle. So the area equals the pi times the radius squared. Okay, well remember, they give us the diameter in this. Right, so we have to remember that the radius is actually going to be half of this. So the radius in this one is 12 centimeters. The radius here is 18 centimeters. And the radius in this last one is going to be 24 centimeters. Okay, and if you want to actually draw the radius, that's okay as well. Some people may choose to do this part where they actually draw the radius and they write that. And they draw this radius, okay, and that's actually 18. They draw this radius and that's 24. Okay, so again, if you want to draw those, that's okay. All right, so now I'm just gonna set up all 3 of these and we'll solve them. Okay, or find the actual area. So for this first one, it's going to be the area will be equal to pi times 12 squared. Okay, for here, on this next one, we're going to set up the area will be equal to pi times 18 squared. Okay, and on the very last one, we'll get that the area will be equal to pi times 24 squared. Okay, so plugging these into your calculator, okay, let's maybe just do the 12 squared part first. And so we'll just do this. So we'll say that the area is going to be equal to 144 times pi. And this is going to be square centimeters. Okay, and then we'll evaluate the 144 times pi. So what I would do is find the pi button on your calculator and I have an old school one here, so I'm going to write second and pi, and it gives me that approximation, and I'll multiply that by 144, and that gives me, rounding to the nearest tenth, 452.4 square centimeters. Okay, and this is my final answer. Okay, again, in the blue one here on our next one with a 36 centimeter diameter, I would say that the area is going to be equal to, figure out what 18 squared is. Okay, 18 squared is 324, so we'll call this 324 pi square centimeters. Okay, and then we'll find our approximation for pi in our calculator, so press second and pi, and then multiply that by 324. And that's going to give me an area of 1017.9 square centimeters. Okay, and on the very last one here, okay, I'll find out what 24 times 24 is. That's 576. So my area is going to be equal to 576 pi centimeters, or square centimeters. Okay, and again, I'll find my approximation for pi and multiply that by 576. And it looks like that's going to give me an area of 1,809.6 square centimeters. Okay, so that's kind of like 3 examples in one. So we're probably not going to do another example of this. I think it's fairly simple.